Okay, we will move to the next topic, which is first law of thermodynamics. Now we explain the concept of internal energy, that it's the macroscopic energy. No, sorry, it's the microscopic total energy. Now, if we have a system shown here, like we have a container with filled with gas and is compressed with a piston. Inside this container we have gas molecule or gas. Now if heat is given to this system, what will happen? Two things happen here. First, the internal energy of the system changes, and also this piston, which is initially here, is now moved upward to this point. So it covers a distance d, and this distance is covered by applying pressure on this piston. So it means that work is done by the system on the gas, by the gas on the system, work is done by the gas on the system. I can summarize it like this. If we give heat energy to this system, what will happen? It's change its internal energy, delta E, minus it also doing work on the system, d delta W, delta Q is equal to delta E minus delta W. Why we have a negative sign? Because the work is done by the gas on the system, which is always negative. If the work is done by the system on the gas, then it can be considered to be positive. From this equation, if I rewrite, I can get delta E is equal to delta Q plus delta W, and this is called first law of thermodynamics. How we will define it? We can define it like this. The heat energy supplies to the system Like here we supply the heat energy to this system, is converted into, is equal to the sum of change in its internal energy and work done by the system. And work done by the system, like the heat energy supplied to this system is equal to the sum of change in internal energy delta E plus the work done by the system. So again, if we can write this equation like this: delta Q is equal to change in internal energy plus minus delta W, the heat energy supplied to this system is equal to the sum of change in internal energy plus the work done. But here I have a negative sign. The negative sign shows that the work is done by the system and its surrounding, which is always taken to be negative. If we rewrite, we get this equation. This is the mathematical statement of first law of thermodynamics. Now if the change is very small, then we can write this equation is dE is equal to dQ plus dW. But here I will use INT, where INT means internal energy of the system. So this is all about first law of thermodynamics, and next we will explain few more things, and after that we will come to the application of first law of thermodynamics. Thermodynamics. But before explaining the application of first law of thermodynamics, I will explain few more terms to clear the concept before using first law of thermodynamics. Thank you. In the next video we will discuss those new ideas before applying the first law of thermodynamics.